This is great. As a speaker, you walk in and you see a coffee machine. A caffeinated audience is a good thing. I teach college, so the idea of speaking in front of people who are awake, it's a nice change.
We also put you to work.
Yep.
Yes.
I actually, one other time I came in, there was a coffee machine. It was a talk I was giving at the Jewish Community Center down in Dallas. And I thought, oh, this is great. They're all going to be drinking coffee. Then I learned that the entire group came from a session before that was tasting Scotch whiskeys. Though, yeah, I was speaking before drunk people, which, as a college professor, again, I'm quite used to. But Einstein, growing up as, a secular Jewish physics nerd, you can't not love Einstein. We all love Einstein. Well, not all of us. There are some who don't love Einstein. They're few and far between now, but back then, there were a bunch who did. Right? My doctoral dissertation, I wrote it at Johns Hopkins in the history and philosophy, the ramifications of relativity theory. And then, as time went on, I got tired of speaking to just, the same 12 nerd professors who were, concerned about the reception of early relativity theory and the questions about the nature of geometry. And I thought, I want to write a book that my eye doctor can understand. I want to talk to normal people. Well, my eye doctor's sort of normal, right? Better now or now? It's like, which one is better. You tell me. But the idea was to write something that connected the work of Einstein to a larger social context. See, the way we teach science, it worries me. I mean, science could not be more important than it is right now, right? I mean, every single political question we deal with, there's some on this side. Yep. Every single policy question we have hinges in some way on science. And if we're ignorant of the ways of science, we're going to make bad decisions that are going to harm the nation, our children, the future. And so you think about how we teach science, right? How we teach science, right? These guys, how they took science at a fine liberal arts college, right? You go in, you sign up for a science class, you go to the bookstore, you buy a $300 textbook, it looks like this, right? You're taking a biology class, you spend $300, and the title of the book is Biology. All that money, they couldn't give you a better title, right? Or Elements of Chemistry, which is actually a very clever pun if you think about it. Right? And what do? You open up the book, there's the first chapter, you read the chapter, and at the end of the chapter there are problems. You do the problems, and for the even-numbered problems, in the back of the book are the answers. Not just answers, the answers. And if your answer isn't the answer, then you did it wrong. You need to go back and learn to do it right. And so the way we teach science, in a certain sense, conveys unintentionally a certain picture of how science is done. That science is a set of questions to which there is the answer. And it's just about creating the right scientific cookbook, getting the right algorithm so that you plug it in, turn the crank, and out come the answers. Well, that's not how real science is done, right? I know I spoke beforehand with some folks in here who are scientists. That's not what science looks like. Science is messy. Science is mushy for a while. It's a process that makes it stronger as it goes. And one of the things that we keep from our students, I think, unfortunately, is the human side of science, right? Because science is done by scientists. I'm a philosopher. I say deep things, right? And scientists are people. Well, most of them, right? If you've eaten lunch with them, you would know, right? And the idea is that people exist at places and at times. And when you look at, right, scientific theories have biographies. They have stories. They come from a place. And when you tell those stories, all of a sudden, you get a deeper sense of what was actually happening. So when we look at Einstein's theory of relativity, right, it has a biography. It has a story. And the hope was to tell that story because it is a story that connects science with politics, with history, with religion. You go to any university or college, we have departments, and the departments own certain topics. I taught for a little while at the United States Naval Academy. I'm a philosopher. We could not even mention the name of the philosopher John Locke. Why? He was owned by the political science department, right? He was their private property, which is kind of funny because that's one of the things that Locke talks about. But it has this sort of mistaken sense that there are these sorts of boxes that things fit into neatly. But, you know, when you really want to understand why we believe what we believe, the story is actually a little bit more complex. And so I started to write this book called Einstein's Jewish Science. And it actually was tricky finding a publisher, in part because of the title. Now, the title is not a phrase I coined. It actually comes from a group of Nazi sympathizers between the world wars. They use the adjective Jewish in an attempt to denigrate the theory, right? They're differentiating it from Aryan physics, real physics, right? And the idea here is that these people were scared. They needed to do something, right? Why? Why take on Einstein? Well, now the idea here is that, well, anything connected with the Nazis, instantly you think, okay, this is just ideological nonsense, just, you know, it's not even worth a trifle. Well, the two people who were really behind the Aryan physics movement were a man named Philip Lenard and another named Johannes Stark, both of whom have Nobel Prizes in physics. These weren't just whack jobs. These were really smart whack jobs. Now, smart people can be wrong. Smart people can be very wrong. Smart people can be dangerously wrong. And so when a smart person says something, even if it's wrong, we need to take it seriously. And we need to look to find the fallacies. We need to look to find the errors within it because they may come back again. And so what I wanted to do was to look at this phrase, Jewish science, and to take it seriously, to think about what it means. Now, why were they saying this? Why did they pick Jewish, right? I mean, any number of adjectives they could have used. Some I won't use here because this is going to be on the internet. My children might see it, right? But the idea is they picked that one. Why? Well, there are actually two reasons. One is scientific, and one is political. And those seem like they're two separate questions, but the fact is with Einstein, they were actually deeply connected. Einstein was a very, very political person. Right? When we think of Einstein, we have this sort of flattened out icon of Einstein, right? Think about Einstein, right? The pictures that come into mind, right? The one with the bicycle are exactly the one where he's sticking his tongue out at the camera. The idea of Einstein is that sort of wise, grandfatherly clown, right? The idea that, right? Goodness. The idea that, right, he was this gentle, peaceful person. No, he was a pacifist, but he also had a personality. Einstein, you know, was the sort of person where if you had power, his thumb was going for your eye, right? And so Einstein grows up in a Germany that was actually very young. It was only unified under Bismarck just, you know, a few decades before he was born. And now countries, they're kind of like love affairs, right? When they first start, all full of fire and passion, and that's the way it was. Now, he was Schwabian, right? He wasn't from Prussia up north, but it was still, even at that time, military parades, right? And there was this sense that Germany was going to be the next great nation, right? The Germans looked around, and every other major country in Europe had had a chance to be the great power, right? The British, the French, the Turks, the Portuguese, right? They all had had their turn. This was Germany's time. And so you had, in the German mind, right, this conflation of German power, of German economic interests, and of German militarism. And it becomes just a part of the general culture to the point where Einstein, who was raised in a completely secular home, a home so secular, they sent him to Catholic school. Right? Yeah, this is a Jewish family. Why didn't they send, there was a Jewish day school. Why didn't they send him there? It was too far and it cost too much. Send him to the Catholic school. Yeah, exactly. The Jews in the room know what I'm talking about. And so he goes there, right? And he hates the schooling. Refers to the classrooms as barracks, his professors as lieutenants. And from a pacifist, that's an insult. Right? And so he leaves Germany, and he leaves Germany as a high school student. His family owned an electronics business. It had gone belly up. They relocated to Italy, right? When he leaves, he does something pretty amazing. He renounces his citizenship. He's not just leaving. He is tearing himself apart from, right? And part of it is he's not going to become an Italian citizen. He gets sent ultimately to Switzerland to finish his education. He's not going to be a Swiss citizen. He eventually does have to claim Swiss citizenship, but for purely pragmatic reasons. But in his eyes, he is a citizen of the world. And so from a very young age, in Einstein's mind, there is this sort of cosmopolitanism, this sense that I am not just of this place, that I'm part of something bigger. And that is really part of a worldview that was part of this new movement that Einstein was a leader in, right? And so Einstein, when he comes back to Germany, and ultimately he does, he swears he's never going back. But then Max Planck, who is in the process of building the greatest physics department in the world at the University of Berlin, offers him a position. And he looks at the people who are there, all people he likes and respects. He's offered a very small teaching load. And so, against his better judgment, the professors know what that means. So against his better judgment, he goes back. And this is right before World War I. And what he sees is something that horrifies him, because he swore he wasn't going to go back to Germany because he thought there was just this militaristic element just shot through the culture, and he was not going to be a part of it. And so against it, he swears he's going to keep his mouth shut. Yeah, that didn't last long. And so he becomes an outspoken political figure. Now, World War I comes, and he is a pacifist. Now, there was, this frenzy, a war furor, not a Führer, that would come later, a furor that overtakes the culture to the point where the Kaiser says, I see no parties, I only see Germans. Because there was such, across the political spectrum, there was such unifying power behind the war. And here was Einstein, one of the few who stood up against it. Now, World War I does not go so well for Germany. Okay? But what's interesting is afterwards, there is this split in the culture. Now, World War I, we often forget about World War I, in part, I think, because World War II brought us the Holocaust, nuclear weapons, and it's just closer in time. But World War I was a human tragedy of just unspeakable dimensions. You have automatic mechanical weapons, you have chemical weapons used for the first time, you have airplanes, you have trench warfare where you have one group dug in here, one dug in here. These charge over here to be mowed down. The next day, these charge over here to be mowed down. Day after day, week after week, month after month, there is nothing but mass death, and they're still in the same trenches. No change. All of this horror, death, for nothing. And so you see, in Europe at this time, before World War I and into, this sort of sense of what is going on, what is happening, who are we? You have to understand, before this period, the Europeans, especially the Germans, thought themselves the pinnacle of human culture. They were the end of human evolution, right? Look at Hegel, who says that German culture is the end of history. All of human history was built up to this time. We are as cultured as human beings could be. And then they did this to themselves. What just happened? And so you get this split. And it really is, we think we have a culture war here. I mean, it was a complete split between those who thought that the problem was science. The problem was this new technology. It dehumanizes us. That's what allows us. We need to go fully back to the old ways. On the other side were those who said, science is not the problem, science is the solution. If you look at science, science offers us a way of being which is completely different. The problem were the old superstitions. The problem was the old church and God and king-based social structures. If you look at science, it's only in science that a French scientist, a German scientist, a British scientist can sit down around a table in friendship, speaking the same mathematical language, working off of each other's ideas, making progress. There is in science, Einstein thought, this cosmopolitanism, this universality. And so you have part of the culture, which Einstein is the symbol of, opposing the more nationalistic conservative elements. And he is doing it vocally. Now, during World War I, there is the confirmation of the general theory of relativity, and we'll get into the details of that in a little bit. But it made headlines around the world, and it made Einstein instantly, I could use the word instantaneously, but he does away with that in the special theory of relativity. Instantly, it makes him an international celebrity. He quips at one point that he suffers from a version of the Midas touch. Everything he says turns to newsprint. And so here's Einstein, this incredibly powerful political figure now. People are taking him very, very seriously. And he is a sworn opponent to the nationalists. He is a political threat to them. Now, you got to understand, after the war, the Weimar government is set up. It is forced to negotiate an end to the war, right? Now, we think of wars usually as an attempt to take over land, right? So there may be more of them, but I think this is the stronger side of the room. Let's declare war. Now, if we were across this border to invade and conquer them, right? We have their leader over here. Notice where he is, comfortably behind the masses. He's not on the front lines. No, no, no. But what we do is we invade and we overthrow their leader. Now, why do you declare war? Well, you look at Germany. The Germans, especially the conservatives, say, look, we didn't lose World War I. We didn't. How do you lose a war? You lose a war when you're invaded and somebody occupies you. Nobody invaded the fatherland. We didn't lose. But if we did, and I'm not saying we did, but if we did, it was because of them. The liberals, the socialists, the communists. Now, in those days, those were three different groups. Nowadays, you can add Kenyans, I suppose. That line didn't go over so well in Texas. I love DC. So the idea is, why do you do it? Well, you do it because it's like the mafia. It's a protection racket. Once you've defeated them, now what do you got to do? Somebody's got to pay for that war. Who's it going to be? It's going to be the losers. And so the Weimar government has to negotiate an end to the war, which means reparations. And the reparations ended up, in essence, bankrupting the country. Now, if you have no money, but you're a government, and you can print money, what's the natural thing to do? Right, you're just going to print yourself out of debt, right? But if you print so much money that you pay off all your debts, there's a whole lot of your money around. And if there's a whole lot of your money around, what happens to the value of your money? Right. Hyperinflation. Exactly. Hyperinflation. And so everyone in Germany is broke. Everyone, including Einstein, who now has an ex-wife and 2 kids. So he really needs the cash. So if you are in need of money and you have any measure of fame, what are you going to do? You're going to give a speaking tour, right? And that's what Einstein does, right? Einstein gives talks. Now, where are you going to give talks? Well, following the advice of that great philosopher, Willie Sutton, right? Where do you go? You go where the money is. And where's the money? The money is in France, it's in Britain, it's in the United States. And so he undertakes a world-speaking tour going to these places. Now, the German nationalists, at the end of World War I, right, they see Einstein. He is being held up as the good German, the new German, the rehabilitated German. They see him palling around with the enemy. They see him sailing on ships under the flags of those people who are killing our brave sons. And they just seethed. They hated him. Not just disliked. It wasn't just, oh, he's a Jew. No, they hated him. The same way that, say, Jane Fonda was thought of during the Vietnam War, or Michael Moore after 9/11. He was seen as a traitor. Einstein was a political figure, and he didn't do anything to dissuade. When he would go over to these places and give talks, he would engage in what we now call dog whistle politics. He would use phrases that clearly went over the heads of his hosts, but the people back home, they knew exactly who he was targeting. He had no love for the German nationalists, and he made that clear. And they thought, airing dirty laundry over, this is just unconscionable. And so they branded the theory of relativity Jewish science. Why? Because what was Einstein's power? Why were people paying so much attention to him? That theory, that darn theory. So if we can undermine the theory, we undermine its political power. And so the attempt was made to undermine relativity theory. And the claim was that it was Jewish. Now, why Jewish? Well, you have to understand, right? That's the political side. There's also a scientific side, right? And we were talking about this earlier, is that at the time, Einstein did do something very radical. It's not just that he proposed a new theory with different concepts. He does that, and we'll talk about that in a little bit. But what he did was something really amazing. It was something that had actually started centuries earlier. But with relativity and then quantum mechanics that followed soon thereafter, physics itself changed in a fundamental way, right? Stark and Leonard both win Nobel Prizes in the early 1900s, the first decade. What do they win their prizes for? For finding phenomena, very subtle, hard to observe phenomena that they discover through painstaking observation. They figure out how to look at nature in a very close, very detailed way, and they find these subtle results that no one had ever seen. And once they found them, now, after the experimental work is done, in come the theoreticians to come up with some explanation for them. So physics, as it was supposed to be done according to them, starts by looking at the world. Physics is in and of the world. You start by connecting yourself as closely as you can with the world, and then you come up with the theory. What happens with Einstein and then with quantum mechanics is the cart gets put before the scientific horse. That theoreticians lead the way with these weird, strange, bizarre theories, and then say to the experimentalists, okay, you figure out how to make this true. You figure out how to come up with experiments and observations that will justify or falsify this theory. And they thought, this is just backwards. This is not how science is done. It's destroying science. Where have we seen this before? Well, you look at the people who were leading the charge, and a lot of them were Jewish. And they said, where have we seen this before? Where you get a certain group of people who are into manipulating symbols and coming out with weird results and then convincing you that it's right. We've seen this before. It's those Jews in the marketplace, right? You go in and you're halfway home and you think you got yourself a deal, and then you realize, I've been hornswoggled again. They got me, right? And now they're not only doing it in the market, now they're doing it to science. And so, because science itself was changing, the thought was, look, the rise of these Jews in academia, in science, is changing the way science is thought of. And so they branded it Jewish science. Now, it seems an absurd claim, right? Science isn't Jewish or Hindu, but it's just science is science. Well, not so fast. Again, scientists are people. people come from backgrounds with ways of thinking, right? What we have in the theory of relativity is a theory of space, time, motion, and gravitation. If you look at the theories, the scientific theories of space, time, motion, and gravitation that came before, what's interesting is they are religious science. Einstein replaces the work of Newton, who replaced the work of Rene Descartes. And I would argue that those two actually are religious science. So let's think about temporally first Descartes. Now, the most important thing that happened in the life of Rene Descartes didn't happen to Descartes. It happened about a generation earlier to Galileo. Now, if there was ever a room where I didn't have to explain Galileo, this is it, right? So Galileo, of course, right, he does not invent the telescope. Some Dutchmen do that, but he is the maker of the first really good ones, right? He's trying to sell them to the military because, again, that's where the money is, right? But those were the days before television. So at nighttime, what are you doing? Right? Nothing, right? I mean, you know, the Real Housewives of Verona were real housewives in Verona, right? And so it's nighttime. You're bored. You got a telescope. You are going to look up at the night sky. The biggest thing up there is the moon, right? You look at the moon through any sort of telescope. What do you see? Craters that go down and mountains that go up, right? What's the big deal? Well, the big deal is, you got to remember, at this point, Aristotle was the official physical theory of the Catholic Church. And Coke was the official soft drink, right? But the idea is that following Aquinas, the church said Aristotle is right. Now, what does Aristotle say? Aristotle, it's interesting, sort of reverses things from what we think. We think physics comes first and then chemistry is just complicated physics. For Aristotle, it's actually the other way around. If you want to understand motion, you have to understand chemistry. Now, for all earthly objects, they're made up of a combination of the four basic elements, which are earth, water, air, and fire, right? Now, when Aristotle says Earth is at the center of the universe, he doesn't mean what we mean. We mean the planet Earth is at the center. He meant dirt is at the center, right? If I had a clod of dirt and I let it go, what would happen? It would fall straight down. No matter where you are, it falls straight down. Now, the Greeks knew the Earth was round, right? Columbus, no, he did not. The Greeks knew. They not only knew that it was round, they knew to a startling degree of accuracy how big it was. So if the Earth is round and wherever you drop Earth, it goes straight in, what do you know? It's spherical, right? So all Earth is seeking. There's no external gravitation. It's the dirt itself that wants to go to its natural place, which is always in the center. Now, they were kind enough to provide me with this bottle of water, so please do join. This is where your dues are going, right? If I was to unscrew the top and tip it over, what would happen to the water? It goes straight down, right? Earth goes down, water hits Earth. I have a 10-year-old. We know what happens. You get mud. And then you get an unhappy mommy, but that's a different issue, right? But eventually what happens is that the soil, right, filters out, the water's on top. These are Greeks. They live on a peninsula with islands. They're doing lots of sailing. They know water on top of Earth, right? Now, if you go under that water and you exhale, what do you get? This is the easy question. We'll get harder. You're underwater, you exhale, you get bubbles. Exactly. This being international sign language for bubbles, right? And the idea is they go exactly as you say, up. Why? The air is seeking its natural place. So you have this sphere of earth, you have this sphere of water, and then you have air out here. Now, if I had a lighter and I were to flick my Bic, don't smoke, right? Where does the flame go? Up. If I turn the lighter over, I burn my thumb. That's a very bad idea, right? Why? The fire always goes up because it's seeking its natural place. So the four earthly elements move the way they do because of an internal property that leads them to seek their natural place and then remain at rest there. But that's different from the things that are from the moon on out, right? They move differently. The sun rises and sets. The moon rises and sets. The fixed stars rise and set. They move circular, which means they must be made of something different. So they're made of a different substance, which Aristotle calls ether. And circular is a more perfect motion, which means ether must be a more perfect substance. And so things made of it must be the more perfect shape. And the most perfect shape is spherical, which my doctor doesn't buy. But the idea is that all things made of it must be perfectly spherical. That's what Aristotle said, and therefore that's what the church held. Galileo looks through the telescope. What does he see? Craters that go down, mountains that go up. Now, people have personalities. I have 2 kids. My daughter's 12, my son is 10. But when each of them was 3 years old, if I would put on a recording of a concert at the end when the applause, my daughter, when she was 3, she would clap along with the record. Right? My son, when he was 3, the applause started, he'd stand up and take a bow. People are different. People have personalities. Galileo had a personality. He was a troublemaker. He saw the craters. He saw the mountains. He knew what this meant. So the first thing he does, he goes to get a priest. Has him look through the telescope. Priest looks through, turns white. Okay. I know what it looks like, but actually, there's an invisible fluid as high as the tallest mountains, making the moon perfectly spherical. Galileo says, okay, you're right. There is an invisible fluid. But it makes the craters twice as deep and the mountains twice as high. I always think that's a funny line. Yeah. He gets himself in trouble, of course. He's hauled up before the Inquisition, right? He's tried. He's found guilty, right? And they tell him, do not write again. Recant what you've said. Do not write again, or die. All right. Given the choice, he recants, right? Everything's fine. He has his friend Barberini, who's a cardinal, and they take these long walks together, and they're discussing astronomy, right? Barberini is taking the Ptolemaic Earth-centered view, right? Galileo's taking the Copernican view, right, where the Earth is going around, and they had these long debates walking through the Italian sunshine, and then the Pope dies. They used to do that. And the white smoke comes out. Who's the new Pope? Barberini. Exactly. Urban the 13th, which came after, I think, Suburban the 8th, who was a patron saint of Honda minivans. Right? And he thinks this is fantastic. My buddy's the Pope. It's a get-out-of-jail-free card. And so he goes and he says, I want to write another book. And it's going to be fair and balanced. And we know how well that works. Yeah, that line didn't work so well in Texas either. So he writes another book. It's called A Dialogue Between Two Chief Systems of the Universe. It's not actually a dialogue, it's a trialogue. There are 3 people, right? One is in the middle. He doesn't know what to believe. One, right, is Galileo's voice, right? He's defending the Copernican view. The other is the church's voice, defending the Ptolemaic view. The name of that character? Simplicio. Translates roughly to bozo. And it just happens to bear an uncanny resemblance to the Pope. Yeah. So he's hauled back up before the Inquisition, and they give him a choice. Either you can recant again and not write on this really this time, or you could die. Now, recanting also meant house arrest, staying for the rest of his life in his nice Italian villa. If you are given a choice between death and an Italian villa, this is not a hard choice to make. Now, the idea is this was a show trial. This was meant to send a signal to the entire intellectual community, and it did. Descartes especially got the message. Now, you got to understand, Descartes is very, very different from Galileo. Galileo, he was out there, right? The way the story is often told, it's probably apocryphal, right? Is at the second trial, after the sentence, right? Under his breath, he mutters 3 words. Yet it moves. What was that? Oh, I said, I've got new shoes. That was not Descartes. Descartes was very different. He was a very, very nervous sort. He knew that what he was doing was really, really, it could get him into trouble, and he did not want to be in trouble, right? He did not, right? And unlike Galileo, who thought, look, the church is just going to have to change, Descartes is different because Descartes is a believer. He is an Orthodox Catholic. Now again, what Galileo gets in trouble for is not saying the earth goes around the sun, it's saying the earth moves, right? The previous pope had convened a group of his top theologians. They had come out with a finding that the earth does not move. And this was made a papal bull, which is probably the worst name for something that's supposed to be true. Right? So the church, the pope, says the earth does not move. On the other hand, Descartes is a man of science, right? He believes in the Copernican picture. So he's now trapped, right? On the one hand, he's a man of science. He wants to say the earth goes around the sun. On the other hand, he really believes in Catholicism. And so the Pope says the earth doesn't move. Now, being Pope comes with two main advantages. One is the hat. It is a great hat. The other is that when you speak ex cathedra, when you speak about matters of doctrine, you are infallible, right? Which, of course, is why the Pope could never be married, because then he'd be wrong about everything. Please don't tell my wife I said that. Then I'd be wrong about that, too. Right? Man with a comfortable couch. So the idea here is that he's caught, right? He believes, the Pope says it must be right. The earth doesn't move, but yet the earth goes around the sun. How can the earth go around the sun and yet not move? How can we have both of these? Well, when the Pope says the earth doesn't move, what does he mean by move? Ooh. Is this pen moving? Well, relative to you it is. But relative to me, it isn't. Maybe that's the, well, no. When the Pope says the earth doesn't move, he doesn't mean it doesn't move relative to, he means it doesn't move. Okay, so that's not going to work. But what do we mean by motion, right? Did I move? Yes. How do you know? Yeah, you change place. You were over there, now you're over here. Change place over time. That's what we mean by motion. Okay, so what do we mean by place? A place is a location in space. Ooh, what do we mean by space? Oh, now we're getting philosophical. Okay, so we can measure the distance between the tip of his nose and the tip of my nose, right? Now, if you can measure something, there must be a thing to be measured, right? I mean, if I was to ask you, how tall is Santa Claus? You can't answer. Why? Santa doesn't have a height because Santa doesn't exist. Even in this room? Really, people? You guys got some work to do.
I'm going to have to edit that out.
Exactly, just put a disclaimer up. TV 14. So the idea here is, if there's a measurement, there has to be a thing to be measured. And we can measure distances, areas, volumes out in space. Empty space, which means because you can measure it, there must be a thing to be measured. So empty space isn't empty. Space is therefore a thing. And if space is a thing, then it can affect other things, right? So let's think about this. What do I have to account for, right? Gravitationally, I have two kinds of motions I'm worried about. One is straight line motion close to the Earth. The other is circular motion farther away. So how can I get straight line, close, circular, far away? Well, we've seen this sort of thing, okay? Let's suppose I had a bathtub full of water and I pull the drain. What happens around the drain? Exactly, this being the international sign language for whirlpool, right? Now, if we were to turn on the tap, so there's always a fixed amount of water in the tub, right? Around the drain, there's a whirlpool. Now, if I take my rubber ducky and I put it all the way out here, away from the drain, what's it going to do? It's going to move around the drain as if it's an orbiting planet. But if I get my rubber ducky too close, what happens? Straight down. Look what we have! straight line motion close to, circular motion far away. So if we posit that space is a substance, and every massive object, every object with mass, causes a vortex, a whirlpool around the object, now what do I have? I have a theoretical account of observable phenomena. That's a scientific theory. It's a scientific theory of gravitation. What Descartes gives us is our first comprehensive theory of gravity, and it is a scientific theory. Okay, but what about the Pope stuff? Okay, now, suppose instead of my rubber ducky, I take a water balloon. I take a balloon, I put a marble in, I fill it with water, I tie it off, right, and I put it out here. Now, the balloon is going around the drain, right? But if you're sitting on the marble, what do you see? The same water. If movement is going from one bit around you to having another bit around you, that marble, according to this definition, isn't moving, even though it's going around the drain. Now, the Earth, because it has mass, keeps its space around it. It has a vortex. And so space is constantly bathed in the same space. The Earth is always surrounded by the same space. So as that bit of space goes around the sun, the Earth is always bathed forever in the same space, which means the Earth isn't moving. It goes around the sun, and it doesn't move. We have modern science. We have the Pope's decree. How clever is that? It's amazing. And it's a scientific theory, but it is one which is developed under theological constraints. It is Catholic science. Right? Now, Newton is at Cambridge, right? A young genius. He is sent to learn the best scientific and mathematical treatises of the time, and that meant Descartes. Newton knew Descartes inside and out, and he was not amused. In part because he was Newton and was never amused by anything. He supposedly laughed once in his life. Okay? Now, he just, space moving, pulling things, nonsense. Well, he's British. Poppycock, right? The idea is space is fixed and immovable. Space is just where things are. It doesn't move things, right? Space is like a three-dimensional piece of graph paper lying underneath of reality, right? And so he comes up with a new theory, his theory of mechanics and gravitation. 3 laws of motion, 1 law of gravitation, and it explains unbelievable amounts. It is just shocking how powerful this theory is. Now, those on the continent who bought into the Cartesian picture, they're not happy with it at all. They say, okay, look, you have this equation that says the gravitational force between any 2 objects is proportional to the product of the masses, inversely proportional to the square of the distance between the centers of mass, along the line connecting them, and is attractive, right? Gravitation is an attractive, it's the Brad Pitt of physical forces. Very attractive. Right? So, why does it happen? Where's the string? What's doing the pulling? And Newton responds with 3 words. Hypotheses non fingo. I frame no hypotheses. Or, more colloquially, moo. I have no idea why this is happening. Now, this is more than a little bit disingenuous. He thought he knew. In fact, there are some letters back and forth to the Reverend Richard Bentley. Bentley was an Anglican minister who was giving a series of talks where he was saying that the Newtonian worldview gave us what we would now call intelligent design. Right? It showed there had to be an intelligent mind creating the world. And Newton writes him saying, "It thrills me that you are saying this, for it is for that reason which I wrote it." He, Newton, thought this was scientific theology. This is why I wrote it. Space, according to Newton, and he says this in several places, is the sensorium of God. Space is God's sense organ. Space is God's skin. God knows everything. God knows I just moved. How? He can feel it. He felt me over there. Now he feels me over here, right? So if you stand in one place and just move very gently, it tickles God. You always have to move before you get scratched, right? So the idea here is he really does think. He says, look, there's only one mistake you're making. You say that gravitation could either be the result of an intrinsic force, there is something in the pen and in the earth that's attracting each other. Or it could be the result of some external force, right? Something outside of it is pushing it down. He says, you attribute the first to me. Pray do not. I believe that gravitation is the result of some agent, natural or supernatural, who can work over almost infinite distances, moving extremely heavy objects, whose name might rhyme with rod. Right? You got to understand, he's a Protestant. The idea is he looks at Descartes and he says, this could give rise to deism, right? Deism versus theism. Theism, right, is that there is an active God in the world. Deism is that you have the perfect clockmaker God who creates a perfect system, winds it, and then goes off to have a beer and play golf or whatever it is he does, right? He, right, as a Protestant says, God is in the world. And so gravitation, he thinks, actually is the hand of God. Oh, sorry. Apparently God's not terribly happy with you. Right? So when we look at Newtonian mechanics, when we look at the physics we all learned in high school, right, where you have the inclined plane at angle theta and the box of mass m, right, and you drop it and there's a coefficient of friction mu k, and after 2 seconds, all of that in a certain sense was motivated by Newton's Protestant beliefs. Now, does that mean that, right, if we're opposing, religion in the schools, now are we going to campaign against physics classes? No, that's not what we're saying, right? But the idea is that when you look at where it comes from, it does come from, in its design, the theological constraints of the theoretician's belief. Newton did see it as Protestant science. So if Descartes gives us Catholic science and Newton gives us Protestant science, now all of a sudden it's not so stupid of a question. Did Einstein perhaps give us Jewish science? Yeah, and the answer is no. We know what he was reading. We know what he was thinking about. He was reading the French mathematician and philosopher Henri Poincaré. He was reading the German physicist and philosopher Ernst Mach. He was reading the Dutch physicist H.A. Lawrence. He was reading the Scottish philosopher David Hume. None of them are Jewish. So it turns out, no, there is absolutely nothing Jewish in the content of the theory of relativity. Now, if you are writing a book called Einstein's Jewish Science, and the answer is no, you keep writing. And so if it's not in the content of the theory, maybe can we think of it in the how? So if it's not in the what, maybe it's in the how. Maybe it's in the methodology. Now, what's interesting is that, and this is actually news to a lot of people, is that scientists have styles. Right? I mean, that sounds weird because we do have this sort of textbook sterilized picture. Right? I mean, it doesn't strike us weird that, artists would have style. You'll see a painting, and it may be something you've never seen before. That's Picasso. Or you hear a piece of music, and within 4 bars, that's Mozart. In the same way, scientists have styles. And what's interesting is there is a style. There's a signature move in Einstein's work that's really something interesting. Now, theory of relativity. 2 concepts, 2 ideas. Stay with me. Covariance and invariance. Okay, covariance. Simple question. Is the pen to the left or right of my hand? And you will say, oh, stop it. Is the pen to the left or right of my hand? And you will say, oh, help me out here. You will say, to the left, right? Left is the one with the L, right? I will say, it's to the right. Okay, so is it just relative? Is it just what, it's what she believes or he believes or you? No! For you guys, it really is to the left, right? I mean, if this guy says, well, I think it's to the right, what do we think of him? Moron! I mean, hypothetically, of course. Right? He's wrong. Once you nail down a frame of reference, there is a fact of the matter. But the fact of the matter will change with your frame of reference. It varies with. It's covariant. Invariance, on the other hand, is that which doesn't. So if I ask you, is the pen between the hands? Yes. And that's true no matter where you're looking from. That's invariant. Now, invariant facts are really important to us, right? They seem to signal something deeper, right? Because if he tells me something, yeah, maybe I'll believe it, but yeah, we all know how he is, right? But now if she tells me, and I know she hasn't been talking to him, and then he tells me, and I know he doesn't know either one of those two, I think, oh, maybe there's really something to it. So when something's invariant, we think, wow, this is deeper. Maybe this is actually real of reality itself. And so what Einstein does that is so revolutionary is he takes certain things that we thought were invariant and turns them covariant. So take something like length. How long would you say that pen is? 6 inches. So if the pen is 6 inches now, how long is it now? 6 inches. It's just moving. Now, Einstein says if I'm going at 3/4 the speed of light across this room, you will measure that pen not at 6 inches, but at 4 inches. To me, it'll still be 6. Well, which one of us is right? It's covariant. From your reference frame, it is 4 inches. From mine, it is 6 inches. It's not an invariant fact, it's a covariant fact. And it's not just length, it's time, right? So if we were to synchronize our watches, right? 1 second on his is 1 second on mine. If our watches are synchronized now, then our watches should be synchronized now, right? They're synchronized whether I'm still or moving. Still, moving, or in the opening scene to West Side Story, right? It shouldn't matter. Time is time. No. Turns out if I'm moving 3/4 the speed of light across here, my watch will seem to you to have slowed. So space squishes, time stretches. Which one of us is right? Well, it's covariant. From our frame of reference, we're both right. And it's not only length and time, it's mass. The faster you go, the heavier you get, which is not reason to tell your doctor you're not going to run on the treadmill. All right? Faster you go, the heavier you get. Now, the way I illustrate this in the classroom, right, and this is the reason why we can't go faster than the speed of light. It's not that it's an engineering problem. It's not that we haven't figured out how. You cannot. Why? Well, here's a chair. What I'll usually do when I'm in a non-carpeted room is push the chair and it'll scoot across the floor. And I say to my students, okay, what just happened? And they say, well, you pushed the chair and it moved. Right. I exerted a force and it gained an acceleration. I bring the chair back. I say, what happens if we add mass? And I'll take a slight young lady, put her in the chair. I say, now if I want to get the same acceleration, what do I need? More force. So I shove the chair and the young lady goes scooting across the floor. And we bring it back. I say, now let's add more mass. And I'll get, a husky gentleman, usually a football player, and I'll sit him on her lap to the hilarity of the class. I say, okay, if I want the same acceleration, what do I need? More force. So if I push that hard, I get a hernia. Right? But the idea, what Einstein says, is that as you go faster, that mass approaches infinite. And if this is infinitely heavy, how much force do I need to accelerate it even a teeny bit? An infinite amount. And an infinite force needs an infinite energy, and you ain't getting that kind of energy. That's why things cannot move faster than the speed of light. All right? So, length, time, mass, all of these things are covariant. Does that mean everything is relative in the theory of relativity? No. There is an important invariant. There's an important thing that doesn't change, and it's what we call the space-time interval. Einstein's professor Minkowski figured this out. Now, between those two snaps was a time and a distance, right? To different observers, the distance will squish and the time will stretch. But if you take the four-dimensional distance between them, that stays the same forever. Okay, time out. He said four-dimensional distance. Philosopher, are we getting new agey here? No. When I use the word dimension, all I mean is the number of numbers needed to specify a location. So think about your address. How many numbers, not numerals, how many numbers in your address? 1. I only need 1 number to know how far down your street to go to get to your house. That's a one-dimensional space. But if we were to go to Manhattan, How many numbers in the address? 2, right? I need to know the street and the avenue. But then you'll get there and you'll realize I need a third number, the one you push in the elevator. 1, 2, 3. It's a three-dimensional space. But if you're going there, and when I give this talk before college audiences, I say, well, if you're going there for a job interview, and then I have to stop and explain to them what one of those is. Well, sorry about your economy. Right? Now, if you have a job interview, you not only need those 3 numbers, you need a 4th number, because there's one before, there's one after. So to uniquely specify an event, I need 4 numbers. That's what we mean when we say time is the 4th dimension. So if time is the 4th dimension, what's the 5th dimension? Yeah, it was a singing group from the late 60s. That usually gets more of a response. Okay, so the idea here is that we have this 4-dimensional measure. And what Minkowski, Einstein's college professor, says in his paper Space and Time, this is a really important paper, he says, henceforth, space of itself and time of itself will no longer be seen to have independent existences. Only a unified space-time is real. So what's real is this 4-dimensional space-time. But the problem is, we don't see 4-dimensional space-time. We each live in a 3-dimensional space and a 1-dimensional time. And we each break it down differently according to our perspective. So we get these different covariances, right? That's how we measure things, in that covariant fashion. But yet we can compute up to some higher truth that we all agree on. And now what's interesting is where else you see that form of reasoning. And here's where the Jewish part comes in, is it's there in Talmudic thinking. If you look at how the ancient rabbi, right? So the Jews have 2 sacred texts. One is the Torah, or as Christians call it, Old Testament, or as my people call it, Testament. Right? And that's supposed to be the Word of God, an absolute truth. But then you have the second book, the Talmud, right? Which is a commentary on it. And in it, one rabbi says this, one rabbi says that, somebody else says another. Well, which one is right? Right? It's a Goyish question, right? It's not a question that Jews ask. Right? It's not that one is right and the others are wrong. They're each, and this is the theological background, each of them are elucidating a part of the higher truth, God's truth. And so what you get is the need to study. When rabbis train, right, you always study with a partner. One argues this way, one argues that way. You argue as hard as you can, and then you switch. And the idea here is that if you're trapped in your own perspective, you'll never get this higher wisdom. Right? Now, it's a very similar move to what we see in Einstein. Now, Albert Einstein was a very religious, observant Jew when he was 8. And then he turned 9. So where does it come from? Does it come from religious studies? No, right? We know that in high school, Einstein did have to go to religion classes, right? He actually had to go in elementary school because it was a Catholic school. He got trained in catechism and got better grades than his Catholic schoolmate. But then in high school, he's sent to basically in-school Hebrew school. He gets this beautiful note on his 50th birthday from one of his old professors of Hebrew studies. And he writes back this wonderful note that says, oh, it's very touching to hear from you. Thank you so much. Boy, I wish I had listened to anything you had said in school. So it's clear he doesn't have a background, right? So we can't say that Einstein is somehow pulling from, right? Well, maybe it was in the air in the community. He was raised in a Jewish community. Well, look, reading minds of living people is problematic enough. Try reading minds of dead people, right? Ain't gonna happen. So is there a causal connection? We can't say that. But it is interesting that it's there. Now, it's there in other Jewish thinkers too. Emil Durkheim, the founding father of sociology. Father was a rabbi, grandfather was a rabbi, great-grandfather was a rabbi, all in France. Also there, but it's not in every Jewish thinker. When you think of the other most important scientific thinker of Einstein's time, you think of Freud, right? Let's think about Freud for a minute, right? So psychoanalysis. Psychoanalysis has a definite spatial dimension, right? The idea here is the mind, as Freud pictures it, is a complex thing, right? So when you say, I made up my mind, that's only a tiny part of your mind, right? That's the ego, the part of your mind that you see, but there's so much more, right? The metaphor we usually use is an iceberg, or if this is Jewish science, a Greenberg, right? So the idea is that the mind as a whole is so much larger, and there are these subconscious elements where all of this other stuff is happening, right? And so what happens in psychoanalysis is that the analyst talks to the patient. Now, there's a dialogue between them. That seems, okay, dialogical. Maybe that is Jewish. But think about how it works, right? The patient is on the couch facing this way, free associating, talking about his dreams, recalling how his controlling Jewish mother had... Never mind. I gave this talk at the library where I grew up. My mom was in the audience. I had to cut that line out. The analyst sits back here, behind the patient, the unseen seer, making occasional sounds. Our 50 minutes are up. From that position, the therapist has privileged access to the subconscious of the patient. The analyst is able to understand why the hysteria, where are these strange behaviors coming from? A privileged access to truth. In a certain sense, what you see in Freud is very Catholic, right? You see the therapist as being a sort of pope figure, right? Having privileged access to the truth. So it's not in every Jewish thinker. So it's not Jewish in that sense. But when we think about Jews, right? Jews are a strange people. Before the founding of the modern state of Israel, they were pretty much everywhere but had nowhere. Wherever they were outsiders. Now, being an outsider does something interesting to you, right? Friedrich Nietzsche, the 19th century philosopher, said that those who are in power get something important. They get control of the language. And when you control the language, you control the concepts by which we make sense of the world. When you're in a minority group, you have no choice but to speak their language. It's their culture, you speak their language. But you also speak your language. And so there's always this sort of double consciousness happening, right? There's always the ability to see things in more than one way. Now, it probably will surprise no one at this point to hear that I do a little bit of stand-up comedy on the side, right? Think about comedy for a minute, right? How do jokes work? Knock, knock. Come on, people. We'll try this again. Knock, knock.
Who's there?
To.
To who?
No. To whom? Right? Think about how the joke works. There's a setup that leads you to think in one direction, and then a punchline that makes you think, oh, I need to be thinking in this other direction. Right? Comedians not only tell jokes, they have to create the jokes. And so, why is it that when you look over time, the great comedians, almost always from minority groups, right? In the 40s and 50s, you had the great Borscht Belt comics, right? In the 70s and 80s, you had this wave of amazing African-American comics. We're now sort of on the back end of a group of Latino comics. What is it about minority members that are so much funnier? Well, there's always this double consciousness happening. It would be natural to think of jokes. And so when we look at Einstein, right, what do we see? We see a science that takes multiple perspectives. Now, Einstein. When we think of Albert Einstein, what's the first thing that comes to mind? The hair. The man changed the way we understand the universe. He was on the forefront of the pacifist movement. He is an icon, and we remember the hair. What is it about the hair? Now, I mean, think about it. Hair is political, right? I mean, when you look at someone, the first thing... Sorry. The first thing you see, I'm almost there with you. The first thing you see is the hair, right? I mean, it says something. Hair says something. And what did Einstein say by having that hair? He said, I'm different. And I'm unafraid to show it. Einstein didn't wear belts or socks. I have shoes on. Why do I need socks? I have pants that fit. Why do I need to wear a belt? Right? Why are you wearing socks? Why are the rest of you wearing socks? You didn't get up this morning and think, okay, sock or no sock? Sock. No, you just grab for the socks. You do it without thinking because that's what you're told you're supposed to do. What Einstein is saying with the hair, without the socks, is saying, I am different and I am unafraid to be an outsider. I am unafraid to be who I am. And that's why Einstein is this icon. He's beloved by Jews, but we all love Einstein. You're in traffic, there's a bumper sticker in front of you with a quotation on it. More often than not, it's Einstein. And that doesn't mean that the driver is Jewish, right? We all love Einstein. Why? Because he does have this sense, right? This cosmopolitan sense that I am unafraid to be me. I'm unafraid to be different, right? We use the word rebel, right? As if it's rebellious to simply be yourself. What's interesting is you see this Jewish style of thought elsewhere that isn't Jewish. You see it in certain feminist writers, and you see it in post-colonial Africana writers. Now, about 20 to 15 years ago, feminism found itself in a place that was this sort of postmodernist, there is no truth, everything. It's in a better place now where they're saying, look, there is truth, but different perspectives give us different aspects of it. And we do need to understand these different angles to understand things that your own reference frame won't give you. The same thing with these post-colonial Africana thinkers. What we're seeing here is a move to talk about thought of people who are outside the mainstream. And so when we say that Einstein's theory of relativity is Jewish, we don't mean it's Judaic. We don't mean it's Hebraic. It isn't. It has nothing to do with any religion. But if you think of Jews as these people who are around, but always a little different, yeah, it is the science of people who are a little different. And lots of people are a little different. So those of you who are and aren't Jewish, welcome to the tribe. Right? And so, in that sense, we can say it's Jewish. Now, is it a slim read? Yes. Right? It's not really Jewish, right? In the way, a rabbi would not be happy with this. Also, the Nazis would not be happy with this. And my feeling is if you can ever do anything to annoy the Nazis, I'm right there with you. So on that, why don't I just say thank you. More than happy to take questions.
You were talking about the invariance, now relative and this and that. But you didn't talk about, you're talking about the covariance, but the invariance was the velocity of light.
Velocity of light is one invariant.
Part that ties everything all together.
Yes. So what happens here is Einstein is working at a time when we had two physical theories. Right? We had Newton, who gave us a theory of gravity and motion. On the other hand, we had James Clerk Maxwell, who gave us a theory of magnetism, electricity, and it turns out light. And now in Maxwell's theory, you get the weirdest thing that happens. You have one constant. Now, constants appear in physical theories just to make the units come out right. And in one of his equations, right, you have this constant for electrical equations. We call it epsilon naught. Epsilon, the Greek for E, naught, just zero, right? And it's just a number in the equation. In the magnetic equations, we have another one, mu naught. Mu being the Greek M, mu zero. And so you have two constants, numbers, just numbers. Now, if you take a constant times a constant, you get a constant. You take the square root of a constant, it's a constant. You take 1 over a constant, it's a constant. You take these two constants, multiply them together, take the square root, 1 over, it's the speed of light. What? This has nothing to do with light. This is about electricity and magnetism. Where is the speed of light? And it is exactly the speed of light. And so the question, what? The speed of light is a constant? That can't be right? Because, Newton says, look, if you're at the airport, right, and you're on the people mover, right, stand to the right, walk to the left, right, and now you've got somebody sitting in Cinnabon, right, and he's watching, right, and there's one person who is standing, moving 2 miles an hour. And there's another here who has a flight to catch and going by at 4 miles an hour on the people mover. how fast does he see this person moving? 6, right? 2 plus 4. Yeah, it turns out it's not. And it turns out that the speed of light, it doesn't add that way. So if I have a flashlight and I'm shining it in his eyes, right? What does he see? Well, nothing. I'm shining a flashlight in his eyes, right? He sees the light coming at him at what speed? Yes, the speed of light. That's trivial, right? But now if I take the flashlight and I move towards him at 2 miles an hour, he should see the light coming at speed of light plus 2, right? Or if I pull it back, it should go at speed of light minus 2, right? Yeah, no. Turns out it's the speed of light. And this can't be right, right? Because Newton is right? I mean, Newton talks about velocities, and so for a long time we were trying to Newtonianize Maxwell. Yeah, it never worked. And so Lorentz, a physicist the generation before Einstein, one of Einstein's heroes, said, okay, just let's see what would happen if. I'm not saying we do it, but what would happen if, instead of Newtonianizing Maxwell, we Maxwellized Newton? And what comes out are 3 of the 4 equations for the special theory of relativity. And he said, look. I'm not saying this is true. He gets the length squishing. But it's as if it's true. And what Einstein does is add one more equation about time stretching and says not only it's as if, it is. Ooh. And so Einstein, you will hear from time to time claims that Einstein was a plagiarist. Well, no, Einstein was a scientist. Science doesn't happen in a vacuum, right? I mean, unless you're vacuum science. All right. The idea here is there are always influences. People learn from people. And what Einstein did was not come up with this out of whole cloth, but what he did was make very important conceptual shifts. So yeah, the constancy of the speed of light was essential to the theory of relativity coming to be. It's not as if it's constant because, well, from the Newtonian perspective, it couldn't be. And of course, Newton's right because he's Newton, right? You don't have Fig Maxwells, do you? Right? I mean, it's Newton. You can't reject Newton, right? And so that's how you can make $1 million. Fig Maxwells. Write that down. So the idea here is, right, no one wanted to, Einstein did. And it was that conceptual shift. And we see that several times throughout his career where he just makes that conceptual move. So yes, the constancy of the speed of light was an essential part of that process.
Why did Einstein never get the Nobel Prize for relativity, not even after World War II?
Okay, yes, we were having this conversation beforehand. Einstein receives the Nobel Prize in 1921, and he receives it for what is called the photoelectric effect. Okay, photoelectric effect. The idea here is if you take a piece of metal and you shine ultraviolet light, so black light, Spencer's fuzzy posters in the 70s, right? You get a black light, you shine it on a piece of metal, what happens is electrons get kicked off. Well, that's not weird because we know that metals, right, have electrons in the outermost shell, just 1 or 2 that they're trying to get rid of. This is why metals are good conductors, right? And light, we thought, because there was good reason to think of it, was a wave, right? Now think about, we all did this in 2nd grade, right, where you have 2 tuning forks of the same pitch, and you strike one and you bring them close together, and then you pull them away, and what happens to this one? Right? The idea being that waves cause things around them to vibrate. And so if light is a wave and light strikes the metal's going to start to vibrate and it's going to kick out some electrons, right? So now if we make the light brighter, and a brighter light doesn't mean you mess with, right, the wavelength, right? It's still the same color. It means that the waves get larger, right? Well, what would happen? Now suppose we had a blanket here with ping pong balls on it, and we put a wave on the blanket, right? What's going to happen to the ping pong balls? They're going to jump up. Now, if we increase the amplitude of the wave, a bigger wave, what's happening to the ping pong balls? They're going to go higher. They're going to leave with more energy. So when we turn up the light, we ought to see the electrons coming off with more energy. Yeah, we don't. We see more of them, but they come off with the same energy. Whoa. What accounts for that? Couldn't make sense of it. Einstein figured it out. Well, figured it out again, maybe a little strong, right? Because another one of Einstein's heroes was Max Planck, who we mentioned earlier, who, with respect to another phenomenon that we couldn't figure out, called black body radiation, figured out they had a curve that was measured by experiment, but our theory said it ought to go like this instead of down here. Now, this we knew was a problem because then you'd get infinite energy, and you couldn't get infinite energy, so nobody could figure it out. And people were trying, and nobody could figure it out. And so Planck said, all right, let's do it backwards. Let's reverse engineer the problem. Let's figure out what fits the curve, what mathematical function, and then we'll see if we can make sense of it. And so he did, and it came out that it would work if we think of light as particle instead of wave. Now, Planck is very conservative, both politically and scientific. Hey, I'm not saying it is, but it's as if. And Einstein, with the photoelectric effect, said, look, I can account for these electrons coming off if we treat light like a particle. Now, the idea here is instead of a wave, instead of the blanket, let's think of light as baseballs. And you have a pitcher, right, with one pitch, right, Mariano Rivera. One pitch, he throws a fastball, right? And now when we turn up the light, make it brighter, he's not throwing harder, he's just throwing more pitches. More pitches would mean more things would get kicked out, but since they're all going the same speed, they'd get kicked out at the same velocity. And so the photoelectric effect is understandable if we take Planck's as if, and as Einstein was wont to do, go, no, it's not as if, it is, right? Light is particle. But wait a minute, but it has all of these wave properties too. Yes. So is it really a particle or really a wave? Yes. Right. And so we see the move. It's there too, right? So the idea here is this actually is a big step along the path to what became quantum mechanics. Now, Einstein does not get the Nobel Prize for years and years and years. Right? It's 1905 when the special theory comes out. It's 1916 when the general theory comes out. And year after year after year, he is passed over by the Swedish Academy. And part of it is because those on the Academy are scientifically conservative. They are hanging on to Newton. And as we discussed earlier, in part it's this experimentalist theorist, right, split. But relativity, they will not give Einstein because that relativity can't be right. It can't be right. It can't be right. In 1921, there is no Nobel Prize for physics given. In 1922, Planck, who is the big name in physics in the world, just decides enough. And he raises a stink, saying, it is an embarrassment. You are harming the prize by not giving it to Einstein. It can't be given posthumously. If Einstein dies, what will people think of the Nobel Prize that it wasn't given to Einstein? And so they came to a compromise. They said, we will give it to Einstein, but it won't be for relativity. It'll be for the photoelectric effect. And so even when you look at, what it is for, it is made clear it is not for relativity. But because it was, in a certain sense, in the scientific community, still a political hot potato. Oh, I'm sorry.
How about in the 1950s? Surely Einstein was alive into the 50s. In 1950, they could have given it to him for relativity. Surely those old guys had died by then.
Yeah, but once you got it.
Well, some people have gotten it twice.
Yeah, there were other people. And with quantum mechanics, by the 50s, Einstein was sort of seen as an old fuddy-duddy who had his time, but now his resistance to quantum mechanics made him seem like he had become one of the conservatives.
Now, I hear that there was somebody who really was trying very hard for Einstein not to get the Nobel Prize that same year.
Yes, there was throughout the committee several members, but there was one who was just dead set against, and he was the last straw who said, okay, as long as it's not for relativity theory. So that was the compromise.
Who was he?
Oh, it's a Swedish name, begins with an S. I don't recall. Somebody has a phone, I'm sure can look it up quickly.
Were any of Einstein's other 1905 ideas attacked the same way that relativity was?
No. Einstein, of course, in 1905, we call it the miracle year. He wrote 4 papers, all of which really changed the history of physics. But it's relativity that really makes him the celebrity. So that's the one they really went after.
I came from, I'm a physicist, but I came from also Eastern background. But I can see some parallels, okay? The yin and yang and Dharma, and that's very similar. Then the one God, then the union of yin and yang, the whole bigger picture. And that's what the West, in the Western tradition, they cannot understand when they read the art of war. They think it's just fight. Exactly. But it's not. It's a peace and fight. It's all mixed in there. So it's dealing with that gray area that's you cannot say either or. It's kind of this two mixture of yin and yang, kind of either harmonized or in conflict.
Exactly.
That's the dynamic. It's very similar to.
I think that's exactly right. If you look at the difference between classical Western astronomy and classical Chinese astronomy, right? They're both looking at the same sky, but they come up with very different systems. Why? Well, the West is coming from this presupposition of a universe created by a single, perfectly rational God. And so what are the Western astronomers looking for? They're looking for evidence of that. They're looking for harmony. They're looking for consistency. They're looking for regularity. And so this is why physicists even today argue from symmetry. Symmetry must be, an element, an indicator of truth. This is actually how we still think. And it doesn't mean it's wrong, but it does have its roots in this theological approach. If you look at classical Chinese astronomy, right, what those astronomers looked for was not the regularities, but the irregularities, the retrograde motions, the comets that appear. And why? Because what they were coming from was a foundational worldview in which you had competing forces. And so you should see these unexpected, unusual, counter sorts of phenomena. And so you're absolutely right that it doesn't mean that it's not science, but how we think in part is shaped by where we come from. And this is why I think, if you go to, I did my doctoral dissertation at Johns Hopkins. And one of the wonderful things about that campus is it is the world in miniature. People come from everywhere. And what that does is, yes, we're all training under the same people, but we all look at things slightly differently. And you learn from people who think slightly differently and enlarge your perspective in exactly a way that I think Einstein is very much the symbol of.
The same way that you look at human body. This is conflicting, in Chinese medicine, the conflicting elements inside your organs, kind of balancing and kind of mixing that kind of thing. It's not just a top-down kind of thing.
Right.
It's kind of interaction, a life dynamic interaction within the body.
And exactly.
It explains.
Science comes from culture. And that doesn't make it non-objective. It just makes it richer. Okay.
Yeah, I was surprised you didn't use what I think is a genuine quote from Einstein, who said that if I am proved wrong, then the French will say I'm a German and the Germans will say I'm a Jew.
I start the book with exactly that quotation.
But if I prove right, the Germans will say I'm a German and the French will say I'm a citizen of the world.
Exactly. And that's precisely it. And, the second sentence is, even the cynics aren't cynical enough sometimes. Here he was successful, and the Germans still didn't claim him. And so off we run, because the world is a complex place. It's a scientific place, but it's a political place. It's an economic place. And for $20, thanks everybody very much.